In this part of trigonometry, we're going to be looking at the sine rule. Sine rule applies to any triangle. So here we have a triangle, ABC, named because of the vertices, and the names of the sides are based on the angle to which they are opposite. So A is opposite A, B is opposite B, and C is opposite C. Sine rule is A over sine A is B over sine B. This is how you use it practically. Alternatively, you can flip it upside down and have sine A over A is equal to sine B over B. And of course, because we're not distinguishing any particular characteristics of each of the angles, that's equal to C over sine C or sine C over C, depending on which on the left or the right of the screen. Let's look at the practical application of the sine rule, and in this case we're going to look at having an unknown side. So here we have a triangle where we don't know the length of one of the sides. You'll notice we've got two angles and we're trying to find one side and we're given the other side. So our sine rule says A over sine A is equal to B over sine B. I'm using this version of the sine rule because I'm trying to find the unknown length, so I put length on top. It just makes the manipulation a little bit easier. Let's now put the letters onto the diagram so that it reflects the use of our rule. So here we have our A's and our B's. So let's substitute. So x over sine 104 degrees is equal to 7 over sine 34 degrees. Sine 104 looks awkward, but it's just a number. And we know that when we're dividing by a number, we want to find the unknown that's on top, we multiply by that number. So when I do that to the left-hand side, I get left with x, and on the right-hand side, I have 7 sine 104 degrees divided by sine 34 degrees. Now's the time you use your calculator, and you come up with the answer 12.15 metres to the nearest 2 decimal places. So, your turn. Here's the diagram. Pause the video, copy and label the diagram and have a go. When you're finished, restart the video and check your answer. So, welcome back. Here we have A over sine A is equal to B over sine B. Put our letters onto the diagram so we can use the formula. Substitute in, so we get x over sine 45 is equal to 17 over sine 34. X is equal to 17 sine 45 divided by sine 34. Use the calculator. X is equal to 21.5 centimetres. Now let's look at how we work an unknown angle. So here's our diagram. So, because we've got an unknown angle, we're using the version of the sine rule which says sine A over A is equal to sine B over B. Step 1, label the diagram so we can use the formula. Substitute in. So we have sine of theta divided by 11 is equal to sine 68 degrees divided by 13. Multiply both sides by 11. So sine theta is equal to 11 sine 68 degrees divided by 13. Now, we want to get to theta. We don't want to know what sine theta is. So we use the inverse function. So when we use it to the left-hand side, we have theta is equal to, and on the right-hand side, we have sine to the minus 1 of 11 sine 68 degrees divided by 13. Quite often you'll find that you can simplify whatever's on that right-hand side. Don't worry about it. Waste of time. Let your calculator do it. So when you use your calculator and use the degrees, minutes, second buttons, you find that in this case it's 51 degrees, 40 minutes, 41.42 seconds. Rounding to the nearest minute is 51 degrees, 41 seconds. Done. Okay, now it's your turn. Here's our diagram. Unknown angle. If you wouldn't mind pausing the video, copy and label the diagram and have a go at doing it. When you're finished, restart the video and check your answer. Okay, step 1. write down the rule. Step 2, label the diagram. Now it's just a case of substituting in. So sine theta in this case divided by 88 is sine 47 degrees divided by 117. Multiplying both sides by 88, we get sine theta is equal to 88 sine 47 degrees divided by 117. Using the inverse function, we now have theta is equal to sine to the minus 1 of 88 sine 47 degrees divided by 117. So theta is 33 degrees, 22 minutes, 20.51 seconds. Rounding to the nearest minute, we have theta's 33 degrees, 22 minutes. The ambiguous case. Consider the following situation. Here we've got two lines, and when we try and swing a length B down from the vertex at the top, you'll see it can actually go in two different directions. One where the angle A would be acute, and the second one where the angle is obtuse. This is called our ambiguous case. Okay, so what I'm going to do to show you a little trick with this one, to understand when you've got the ambiguous case, I'm going to label the acute angle down at B to be P, the acute angle inside the isosceles triangle to be R, so you've got two of them on the base, and the obtuse angle at that point A in the middle there is AQ. Now we know that P plus Q is less than 180 degrees because we've only got two angles of the triangle. If we look to the centre, we know that Q plus R equals 180 degrees because you've got angles on a straight line. So therefore P plus Q from the first equation is less than Q plus R, second equation. Take Q from both sides, we have P is less than R. So if we've got this, you've got an ambiguous case when, first off, the side, such as B, is shorter than the side that's A, and the angle you get with your calculations when you do them is bigger than the angle you use in the equation that you solve. Simple. And the other angle is going to be 180 minus R, which you know from the work we've done already on looking at the sine, cosine and tan of angles that are greater than 90 degrees. So let's work in an ambiguous case. So here's a diagram. Theta is the unknown. First step, we notice that the length, which is the B, is shorter than the length associated with the angle that we don't know. Here's our sine rule. So let's now put on our letters to reflect our use of the sine rule. Substitute in sine theta over 37 is equal to sine 34 over 25. So sine theta is 37 sine 34 degrees divided by 25. So theta is going to be sine to the minus 1 of 37 sine 34 degrees divided by 25, which is, to the nearest minute, 55 degrees, 51 minutes. Because 34 degrees is less than the 55 degrees, 51 minutes that we've just calculated, we've got an ambiguous case. So theta can also be 180 minus the 55 degrees, 51 minutes. In other words, theta can be 124 degrees and 9 minutes. Your turn. Here's your diagram. As always, pause the video, copy and label the diagram and have a go. When you're finished, restart the video and check your answer against mine. Hopefully I'm right. So here's your turn. Continued. Here's our diagram. Here's our sine rule. Step 1, label the diagram. Step 2, substitute. So sine theta divided by 82 is equal to sine 57 degrees divided by 73. Multiply both sides by 82. Sine theta is 82 sine 57 degrees divided by 73. Using the inverse function, theta is going to be sine to the minus 1 of 82 sine 57 degrees, all divided by 73. Let your fingers do your walking on your calculator. Theta is 70 degrees 24 minutes. Because 57 degrees, the one you used in your calculation, is less than your 70 degrees 24 minutes, theta can also be 180 minus the 74 degrees 24 minutes. So in other words, it can be 105 degrees and 36 minutes. That's the ambiguous case concluded. Good luck with using the sine rule.